For this problem, we have to kind of go back to what we talked about in a previous section. We have to know how to do a derivative of the e on this one. Now we're still going to follow our same process for doing implicit differentiation, but when we do that, we'll be applying the derivative to all four of these terms separately. And when you get to this term, we've got to apply that special rule for e to the u. So the derivative of e to the u is itself. So derivative of e to the u is e to the u, but then you have to multiply it by the derivative of the exponent. So let's do that for the first one. When we do the derivative of e to the xy, it's going to be itself. So derivative of e to the xy is e to the xy, but then we got to multiply it by the derivative of xy. When you do the derivative of xy, because you have two things multiplied together, that requires a product rule. Okay, so we got the first thing, x, times the derivative of the second. When we get to that point where we're doing derivative of y by itself, the derivative of y is dy dx. Plus the second thing, y, times the derivative of the first. Okay, derivative of x is going to be 1. Remember, whenever you're doing derivative, the variable on the bottom, if that appears in the problem anywhere, you're going to do a normal derivative on that. So when I got to the point where I'm doing the derivative of x, I'm just going to do normal rules for that. That's why I got a 1. That's also why when you come to the second part here, you're going to do that derivative normally too, and that one you'll do power rule. 2 comes down, x, subtract 1, and you get 2x. So I've done the derivative of the first two terms. This whole thing here is the derivative of e to the xy. Then I just did the derivative of x squared. Now I want to do the derivative of the third one. I have a minus. Okay, now these where you have a y raised to a power, what you do is you do the derivative of the outside, and then you got to do chain rule, so you got to have to multiply it by the derivative of y. So 2 comes down, I get y to the first power, and then times the derivative of the inside, which in this case I'm doing the derivative of y, which is dy dx. Derivative of 10 is going to be 0. So I'm done doing the derivative, and now I just have to solve for dy dx. So I want to first distribute this to get rid of the parentheses. So when I multiply that, typically you're going to put the x out front. The order really doesn't matter how you write these because it's all being multiplied together. But typically if you have a single variable, you'll probably write it out in front like I did there. So you write the x in front of the e. And then that's it. The next one will multiply by y. Again, I'll put the y in front, and I get this. The rest of it, I'm just going to go ahead and write all of it out, and that completes that step. Okay, so I've just multiplied it out, and I got my separate terms. I need to solve for dy dx next. To do that, you need to have all the terms that have dy dx in it. You're going to put that on one side of the equation. So I have x e to the xy dy dx, and then I have minus 2y dy dx, and then so those two terms, those are two terms I have together there. They have the like term dy dx. Now everything else that does not have dy dx in it, I want to move that across the equal sign. That's the whole idea here. Once you take the derivative, you always want to write the terms that have dy dx in it together, so that way you can factor out dy dx and solve for it. So I'll put those together. Everything else goes across the equal signs. I have a minus y e to the xy and a minus 2x. All that goes across. Next, I'm going to factor out the dy dx from both those terms. So factoring out dy dx, I get x e to the xy minus 2y. So factor that out. On this side I get minus y e to the xy minus 2x, same thing I had before. The last thing you want to do, divide both sides by what's inside the parentheses, and that's going to get you your answer. So hopefully you've gotten all these steps down here. I need to erase first two lines here so I have some space to write the final answer. Your dy dx is going to be this part here divided by the part in the parentheses. Negative y e to the xy minus 2x. On the bottom we have x e to the xy minus 2y. And there's nothing we can do as far as simplifying here because the minus signs, you can't cross cancel anything out, and there's really not anything that you could factor, so we'll just leave our answer in that form.